Do you know some elements of the periodic table does not undergo chemical reactions? Let's see why. Upon studying the electronic configuration of these elements, it is observed that all these elements except helium have 8 electrons in their valence shell. Let's observe the electronic configuration of the elements helium, neon, argon, krypton, xenon and radon. Atomic number: helium 2, neon 10, argon 18, krypton 36, xenon 54 and radon 86. Let's observe its electronic configuration. These are the various shells in which these electrons will be distributed. Helium 2, so 2 in the K shell. Neon 10 to 8. 18, how do we distribute? 2, 8 and 8. 2, 8, 18, 8. If it is 54, 2, 8, 18, 18, 8. And if it is 86, 2, 8, 18, 32, 18 and 8. So what are we observing? That in their electronic configuration, these elements, they have 8 electrons in their valence shell except helium, which has 2. Thus, it is concluded that if elements have 8 electrons in their outermost shell, they become stable. This rule is known as octet rule. On the other hand, if elements need only 2 electrons in their outermost shell, to become stable, if it needs only 2 electrons in the outermost shell to become stable, this rule is known as duplet rule. Therefore, atoms which do not have 8 electrons in their outermost shell tend to combine with other atoms. I repeat, therefore, atoms which do not have 8 electrons in their outermost shell tend to combine with other atoms to complete their octet or duplet and attain stability. How do atoms attain octet or duplet configuration? Or in other words, how do atoms attain stability? Atoms either transfer electrons from one atom to another, or by sharing their valence electrons, they attain octet or duplet configuration. In my next video, I will be explaining how atoms attain stability in detail. Thank you for watching.